So we want to calculate the maximum height that a cannonball is going to reach if the cannon is initially on top of some sort of hill or cliff. So we can't use any shortcut equations since we have an initial height that the cannon's on. Now, we'll typically be given what our height is, we'll be given an angle, and we'll also be given an initial velocity, and we'll be asked to calculate this maximum height right here. This equation will give you the time that you reach your maximum height. You take your initial velocity, which we have here, you take your angle, which we also have here, and then g is going to be 9.8 if we're on Earth, so 9.8 meters per second squared. Now, if you plug everything into this equation, you should get this right here. And if you plug this into your calculator, make sure you're in degree mode when calculating the sine. You should get an answer of approximately 1.52 seconds. So we have the time that we're going to reach our peak. And now what we want to do is we want to find the distance that it's going to be in the vertical direction up at the top here. So we can calculate that using this general kinematics equation right here. Notice though that we need to find v0 in the y direction, so we can't just use this v0 right here since this is a general v0. We want to find how much v0 travels upward in this y direction. So the way that we can do that is we can use this equation right here, which will give us v0 in the y direction, and this also includes the sine of our angle here. So if we take this and plug it in here, we can update our equation to look like this. So now what we need to do is just plug in the given variables. We have a v0, we have an angle theta, and we have a time that we just calculated right here, and we plugged in 9.8 for g. So we can go ahead and plug in everything into this equation, which will give you an equation that looks like this. Notice how we took 21 and we plugged it in for v0. We did the sine of 45, which is our angle, and notice for t, we plugged in 1.52, which was what we calculated right here. Also notice that I took 1/2 of 9.8, which is 4.9, and I just wrote that out right here. Now, if you simplify down this left-hand side of the equation right here, what you're going to end up with is 22.57. And if you simplify this right-hand side of the equation down, what you're going to end up with here is 11.32. Now, 22.57 minus 11.32, that's going to give you 11.35. So 11.35 meters is the height that you're going to get to from the cliff. But notice this doesn't calculate the maximum height. All this calculates is this distance right here. So 11.35 meters is how you've traveled from this cliff being ground level. But if we want to calculate the total distance right here, what you need to do is factor in this height that we're initially at. So all we need to do is take our initial height and add it to the delta y that we just calculated. Well, our initial height was 50, and our initial delta y was 11.35. So if we add these two numbers together, we're going to get 61.35 meters. And that right there is the maximum height that this ball is going to travel when you launch it from a cannon off of a 50-meter cliff. Now, I've seen people have been commenting on my videos telling me that they get kind of lost in these more complicated ones. So here are the steps of each equation. We started with this equation and solved for t. We plugged t into this equation, and then we solved for the maximum height right here. Here are the 3 steps. Here are all the variables in a diagram. That is how you calculate problems like this.